I can record here. I tried to set it up on my iPad and it was working earlier, so I'm a little bit confused, but whatever. It's 1:14. Do you mind closing the door back there? Thanks. Okay. Happy Tuesday, I guess. Fun. I posted an assignment on Moodle. So that's due next Tuesday at midnight. Okay, so you just do the Moodle quiz. Should be pretty straightforward, right? I don't know what's up with you guys. You're all anxious for work. You can do practice problems without me assigning them. That's an idea. If you're worried, okay. Yeah. So assignment 1. All right, we have to stop talking now. Or I keep talking, you stop talking. It is posted on Moodle. Okay, and it is due Tuesday, October 2nd at midnight. Or 23:59 actually, because midnight gets confusing, right? Is it the beginning of the day, the end of the day? It's at the end of the day, just like you think it is. Okay. So I'm not accepting any late assignments, right? You're just doing it online. There's no reason, well, there's never a reason for a late assignment. So no late assignments will be accepted. Okay. So make sure it's 10 questions. You're gonna work through it, submit it. I think you can even retry it. I set it to do the average of your of each of your submissions if you submit more than one. But I also set it so you should be able to just check your answers. It won't give you the right answer in the submission, right? But so you can check your answer, make sure it's right before you submit it. Okay? So I think that's pretty reasonable. Get that done, right? And then yeah, hopefully that satisfies your need for work. Okay, don't worry, there will be plenty of work to do. I also realized that without Slack, right, because I'm not using Slack, I gave up on it. My phone number, in case you have to text me with questions, because usually that's what I do. I wanted to move it to Slack so we could kind of message in there, but anyways, so if you have questions, you can email me or text me at 250-864-8386. I just find that's easier sometimes, a little quicker. The problem is I don't have mark unread. So if I accidentally read it and I can't reply right away, it sometimes gets lost. That's at your own risk. Okay, this is also my new Zoom, my Zoom room. No, it's not a Zoom room. It's just a Zoom meeting ID. So from now on, all the lectures, if you go through the link that I posted on Moodle, right, it'll take you to my meeting, right? And it'll always be at 250-864-8386. Okay? So convenient, right? Cool.
If we're like sick at home or whatever, can we join that and watch during class?
Definitely.
Perfect.
Yeah. Yeah, so you can join the meeting from home during class, right? Or later on, I'll post the video on YouTube like I showed you guys last day. And so I posted all the videos up there, and I'm going to try to stay on top of it and post them as quickly as I can, but who knows, things come up. Okay. Any other questions before we get started? Cool. All right. So let's do a little bit of review. Last day, we talked about two different ways that we can essentially maximize a profit function, right? We have linear programming, where we have a profit function and a set of restrictions. We graph those, and then we find the points of intersection, and then that's how we find our maximum profit, right? Or if we have a different type of function, right, then we can take the derivative of it. I know you guys love doing that. We'll do an example. I'm just realizing I forgot to make up a better one than the one I did on the fly yesterday. Hopefully I'll do better. Right, we take the derivative, we set it equal to 0, and find the x that makes the derivative 0, and then evaluate the function, and that's your maximized profit. Right. So just two ways of maximizing the profit. So we talked about linear programming, to maximize a profit function, given a set of constraints, the first step, right, was to graph the constraints. Second step, right, was find all the points of intersection. Find all points of intersection, which can require a little bit of math, right? So find all points of intersection, and then evaluate the profit function at each of those points. Evaluate the profit function at all points of intersection And then finally, right, the point that maximizes the profit function is the optimal solution. The point that maximizes the profit function is the optimal solution. Then we talked about maximizing a profit function using calculus. Maximizing a profit function with calculus. Fake calculus. Well, it was sort of real, but kind of fake because we didn't talk about any of the theory, really, right? Okay. But we said that a derivative of f of x, right, just a little reminder, we said a derivative of f of x, so any function f of x, is denoted by f prime of x, right? We throw that prime on there to show that it's the derivative. And if we are finding f prime at a, right? And f prime at a is the slope of the tangent line. The slope of the tangent line at x equal to a. Okay. And so we said that if we have a curve that goes kind of like this, right? As a fact, the highest point of that, right? If this is a profit function, right? The maximum profit is at the highest point, right? And just as a fact, the highest point or even the lowest value or the lowest valley has a slope of 0 for the tangent line, right? And so we said that, okay, we're going to find the derivative, set it equal to 0, right? To force it to find that point where the derivative is 0. And then we trace it back to find the value of x that makes that true, right? And then we use that value of x to evaluate the profit function. Okay. So we said that since the slope at the maximum point of f of x will be 0, we set f prime of x, right, the derivative, equal to 0, and solve for the value of x, that makes f prime of x equal to 0 true. This value of x maximizes your profit function. Maximizes your profit function. Example, I might say maximize the profit function that is, now let me see if I can remember where I went wrong yesterday. 4x squared plus 2x plus 3. Let's try that, hopefully. All right, so that's a question, kind of a sly one, like looks so little, right? But there's a lot that has to happen, right? So our first step is find the derivative. The profit prime of x. So we said we're going to give it a bump from the right, right? The function a bump from the right, and then the powers of x will kind of fall down in front and multiply the coefficient that's there. And in that bump, we decrease the powers of x by 1, right? And so essentially, if you have x to the power of 2 as your highest power, your derivative is going to have a highest power of 1, right? So now it's getting smaller, essentially. Right, so the derivative of this profit function would be -4 times 2, right? I'll write out all the technicalities and then show you where you can skip to if you're comfortable, right? X to the power of 2 minus 1 plus 2 to the 2 times 1, technically, right? X is just x to the power of 1 times x to the power of 1 minus 1 plus 3 times 0, right? Or we can just remember that constants, the derivative of a constant goes to 0. 3 times 0. I'll make a little note here. This is really 3x to the power of 0, right? As x to the power of 0 is just 1. So, right, we would bring that 0 down in front and then it all goes away. Right? So, or if you wanted to skip to this next step, that's fine by me, right? Just seeing -4 times 2 is -8 times x plus 2. Right? So our derivative becomes a much simpler function than our original profit function. Right? So this is our derivative of our profit function. Great. So now our second step, right, would be to set the derivative equal to 0. So I'll say the derivative of the profit function, I'm forcing it to be 0, but it's also equal to -8x plus 2. And I'll add on here, set the derivative equal to 0 and solve for x. Sneak that in there. That's what we're doing. So 0 equals -8x plus 2. So then we want to solve for x, so we can bring the x over to the left-hand side if we want, or the 2 over, it doesn't matter. But we get 8x is 2. So x is 2 divided by 8. Or 1 over 4 if we want. But I'll just leave it as 2 over 8. So, oh yeah. Yes. Yeah. Just because as a fact, right, if you're imagining kind of this curve here, right, here's your profit function. Then at this point, that's the maximum, right? So we've decided that that point is at 2 over 8. Okay. But also, just as a fact, the slope, of the tangent line and the slope of the tangent line is the derivative. So that's why we have to set it equal to 0. At all other points, the slope will have some non-zero value, but yeah. So yes, always. Okay. So now we found the value of x, right, that maximizes our profit function. So now we are going to evaluate the profit function at x equals 2 over 8, or 1 over 4 if you like. I don't simplify because in the end it doesn't matter, right? 2 over 8 is the same. So evaluate the profit of x, which we said was -4x squared plus 2x plus 3, I think. Nice. At x equal to 2 over 8. So then we can say that the profit at 2 over 8 is -4x, oh, sorry, not x squared, 2 over 8 squared, plus 2 times 2 over 8, plus 3. Bust out our calculator here. 2 over 8 and squared. I'll just write out a little bit of work here, 0.0625, right? 2 over 8 squared is 0.0625. Plus, this would become 4 over 8 plus 3. I'm mixing fractions and decimals just because in the end, I'll just use a decimal. Okay. Because profit is in monies, right? So we don't talk about money in fractions, so we're going to need decimals anyways. So 0.0625 times -4, -0.25 plus 4/8. $3.75. Hey, what a great profit function I made up on the fly the second time around. Yeah. Yes. You are so right. Thank you. Yeah. I missed my negative. Still good. Still good. Cool. So then the profit, right, is maximized at x equal to 2/8, but the maximized profit is 3.25. So the maximized profit is 3.25 units. Hundreds, thousands, millions, whatever it is. Just this. Yeah. Just this. Cool. Any other questions? Yes. Yeah.
Profit x equals, like from the previous example,
Yeah.
x plus 1.2y.
X plus 1.2y. No, it only works for powers of 2. So x to the power of 2. Yeah. Good question though. Yeah, because that would be a line, so the slope would never be 0, so it wouldn't work. Yeah, we need that curvature. Any other questions? Cool. All right. So that's kind of our the end of our review. We will, I think I lied to you last day when I said we would not be doing derivatives anymore. We touch back into it next day, and then we're not doing derivatives anymore. Okay? But same idea, just derivatives of polynomials, just like we were doing. We'll deal with that when we get to it. So section 3.2 is on merchandising. And it's a little bit tedious just because there's a lot of definitions, right? What we need for all these formulas is we need definitions, right? We need to know what everything is. And when we read a problem, we need to know how to classify everything that we're given, right? And so I've got some formula sheets for you guys. Let's see here. Take one, pass it down. There we go. Cool. So these are yours to keep. They've been used before in a final exam. So if you get a really messy one, just let me know and we can swap it out. But those are yours, so you can do whatever you want with them. For the tests, I'll give you clean ones, right? You have to use my clean ones for the test. So you're welcome to write on these, but you can't bring those into a test for obvious reasons. Okay? So maybe don't look at it too closely. It's a little bit terrifying. So just kind of put it to the side for a little bit. Good question. Fingers crossed. That's okay, you're allowed. I'm just on high alert. Okay. So, merchandising right? If you're looking at your formula sheet, oh, any extras? Did everyone get one? Oh, yeah, that's pretty good. All right. Wait, that one. Merchandising, right, is the first section on your formula sheet. So slowly but surely, we're going to plug through all these formulas and we'll manipulate them and work with them and just kind of get to know them a little bit better. Okay. So let's start with some terminology, right? Kind of get it under our belts. So the list price, let's start with the list price. The list price is going to be the suggested retail price, right? So the final price that the manufacturer is suggesting that we pay for some item. Okay. So it's the price at which a product is suggested to be sold. That's right. So by the manufacturer, right? What we find is that stores don't necessarily sell for that price, right? So this is just the suggested retail price by the manufacturer. Say that again. Sure. Oh yeah, but they actually cost more. Yeah, usually more. Yeah. Or like at Winners, where it's like, oh, it's $99 suggested retail price, whatever, $120 or something like that. Okay. So the list price, we're gonna denote, so denoted by a capital L, right? So looking at your formula sheet, right? You have, you see a capital L twice on there. Right? So that's going to be your list price. Okay. And then the next thing we're going to tackle is the trade discount rate. Okay. So we kind of have a good idea of how these things work, right? We have a distribution chain, right? So we've got some manufacturer, they sell to someone who sells it maybe to the store, right? Or maybe there's another middleman in there, right? Until eventually we pay the highest price, right? As consumers, right? And so at each step, right, everyone's paying a little bit more than the previous step. Right? And so if we're working backwards, then those would be trade discounts. Okay. So the trade discount rate, okay, is applied at each step of the distribution chain. So there can be lots of different steps, right? And so each of those steps could have its own discount rate, right? So if there's only one discount rate, we denote it by a lowercase d, right? Which you'll see in the first formula, right? Or if there's multiple discount rates, then we just denote them by a lowercase d with a subscript 1, 2, 3, 4, 5, blah, blah, blah. Okay. So it's denoted by a lowercase d, or d subscript 1, d subscript 2, d subscript 3, etc. in the case of multiple discounts. Oops. In the case of multiple discounts. So if we're just looking at our formula sheet, right, we've been looking at these top two formulas, both of which give us N. N is the net price. Okay. So the net price is the price to acquire a product at each level of distribution, right? So if I'm running a store, it's the cost to me to buy this product, right? And then I sell it at presumably the net price. Right? So it's the price to acquire the product at each level of the distribution chain. At each level of the distribution chain. And it's going to be denoted by a capital N. So we can say something like this, that the net price is going to be the list price minus the trade discount. Right, so if I'm a store, then the price to me, right, is going to be the price that someone else is going to pay for it minus whatever discount I have. Right? And so we can shorthand this and say that N must be L minus the trade discount is the list price, right? It's a discount off the list price. So it's the list price times D. Or if we're collecting the common L's, right, we can pull out the L and say that L times 1 minus D. And I'm just showing you how we get to that formula on your formula sheet, right? But this one is on your formula sheet. Put it in a little cute box. Okay. So as long as you know how to use that last one, that's good. Okay. Cool. Or same idea, right? Or with multiple discounts, we can do the same thing, but we would arrive at N is the list price times 1 minus D1 times 1 minus D2 times 1 minus D3, et cetera, et cetera. This is also on your formula sheet.
Both of those mean the same thing. It just depends on how many discounts there are.
Exactly. Yeah. So, I mean, technically, we would only need the one for multiple discounts, and if there was only one, well, you only do one, right? But we have both of them on there. Sure. Okay. So, let's do a little example. I've got them pre-pictured and ready to go. So the first one that we're going to look at is going to be example 78. It's a little, I couldn't get the page to lay flat, so I had to kind of, it's like, whoa. And it's a little hard to read if you're trying to read it, but I'll read it to you, or maybe you have your textbook with you. So example 78, Rawlings is offering a trade discount of 38% off bats to sporting goods stores. So what will be the cost to a sporting goods store to purchase a bat listed at $135? Okay. So let's start by just outlining the things that we're given. All right, we're given that the list price is $135. Okay. And we're told, so presumably Rawlings is the manufacturer of these bats. Okay. So the trade discount that they're offering is 38%. Or, as we know, right, if we're doing math, we can't use the percentage, right? We have to use our decimal values, so or 0.38. Right. Eventually, I'll just move towards writing the trade discounts in decimals, right? But I'll do both for a little bit. Yeah. Cool. So we want to know what will be the cost to the sporting goods store, right? That's the net price. So we want to solve for N. So N is the list price times 1 minus D. Question? No. N is 135 times 1 minus 0.38. We have to deal with the brackets first, right? Simplify it. So 1 minus 0.38. So we have 135 times 0.62. So N is 0.62 times 83.7, but because we're talking money, right, we should probably report it to 2 decimal places. So 8370. Okay. How about we do another one? So example 80. I'll just sneak it from here. Come on. Oh, wants a little bit of space. So example 80 says TI calculators are sold to the retailer at a net price of $32.15 per calculator, while the retailer sells the calculator for the list price of $43.95. What was the trade discount given to the retailer? Right, so now we're trying to find the discount. Good. So we're told, right, that the net price is $32.15. And we're also told that the list price is $43.95. And we are asked to find D. Okay. So same formula, right? N is the list price times 1 minus D. N in this case is 32.15. List price is $43.95 times 1 minus D, and we're trying to solve for D. So we're trying to get D on its own, which means we have to divide both sides by $43.95. All right. So we get $32.15 divided by $43.95 is 1 minus D. Ditching the brackets because we don't need them anymore. Right? You can keep them if you want, but it doesn't matter. So 32.15 divided by 43.95. Sorry, I missed that. I had a typo. 32.15 divided by 43.95. I get 0.731513083 is 1 minus D. Now, just a reminder, I'll write out all the decimal places. You don't have to, right? As long as you're keeping all your decimal places in your calculator, that's fine. Right? But I'll write them out just so that if you're looking back at my notes, then you can make sure that you're getting the same answer. Okay. So just keep that in mind. Okay. And to solve for D, I'm going to do a little switcheroo because, right, I want to get D on its own. So I could put the D on the left-hand side and subtract the 0.73 from the right-hand side, but I'm going to do it in one switcheroo. Okay. So I've got the D here and 1 minus 0.731513083. And because I want to save all my decimal places in my calculator, what I'm going to do for now before because we haven't talked about storing values, right? So I'm just going to make this negative and then add 1. That's the same thing. Right? So negative 0.73 plus 1 is the same as 1 minus 0.73. Right? So I get a D of 0.268486917. So the trade discount is approximately 26, I'll go to 2 decimal places, 85, 26.85%. On the test, for example, if it's important, I'll tell you, give your answer to 2 decimal places or 1 decimal place, right? So as long as you follow my instructions, then you're fine. If there are none, then go till you're happy, right? If you wanted to go 26.8, that's fine too.
I'm struggling here. How did you get that number in your calculator?
Which one? The 0.73?
0.2.
So do you have the 0.73 there? No?
I tried.
That's okay. It's just 1 minus the 0.731513083. That'll do, yeah. Okay. Cool. So any questions about that one? Great. All right. How about another example? Sneak another one. Oh no. Okay. Okay. I have one today. Thank you. I know. I didn't plug it in because my iPad was all charged and I thought I was using that. But I can't have my phone running out of battery.
Yeah.
It's like there's still many hours left in the day. Okay. Great. So let's do example 81. We'll kick it up a notch, especially with this page curl. Rona can purchase bags of soil. Oh. No worries. Good question. Are you guys not getting the same? Maybe the examples have switched. It is example 81. I have it on page 67. At the top. How are we doing? Is it there? Cool. All right. So Rona can purchase bags of soil from their distributor for a list price of $3.25, less discounts of 25% and then 10%. What's the net price that Rona pays for a bag of dirt? So now we have that multiple discount scenario, right? But that's okay. We can handle it. right? And so first we'll outline what we know. Okay. So we're told that the list price is $3.25. And the first discount is 25%, right? Or 0.25. And the second discount is 10% or 0.10. And we want to find N. Find the net price. What is the net price that Rona pays for a bag of dirt? Yeah.
I'm just having a question to understand a little bit better. What is like a situation of that the list price would be less the discount of 25% and then 10%?
Like if it was one time come off the retailer and then you got a discount for paying on top of it.
Yeah, maybe it's like a bulk discount. Hello. Thanks. Thank you. So I can imagine maybe a scenario where they say, okay, you can get 25% off. Hello.
Brutal. It's ridiculous.
So you get 25% off just because you're a distributor, right? And then maybe if you buy X amount, then they'll offer another 10% off.
Okay.
Something like that.
But it's something very like real life.
I think it happens, but they would probably just report it as one discount, and we'll talk about how do we find this as just a single discount in a little bit.
Okay.
But yeah. Okay, so we've got our second formula, right? The little bit bigger one, because now we have multiple discounts. Right? So we have N is L times 1 minus D1 times 1 minus D2. Right? Working with multiple discounts. Okay. All right, so our list price was $3.25. And the first discount minus 1 minus 0.25. And then minus 1 times 1 minus 0.10. Okay. So N is going to be 325 times 0.75 times 0.90. Okay. So we have 325 times 0.75 times 0.9. So I get a net price of 2.19375. Remembering that we're talking prices, right? So we need 2 decimal places. So the net price is $2.19. Okay. So basically, I'll show you I think I have the worst one coming up here. Yeah, here. So here's probably as bad as it can get for this type of problem. Okay. So we're going to do example 82. So this is that kind of lump sum. Yeah. So discounts of 25% and 45% were given on the purchase of wine. The list price for the wine was $32.50 per bottle. So part A, what was the net price to the retailer? That's fine. And then that's what we just did, right? Same thing. And then part B, what single discount would be equivalent to the 25 and 45% discounts, right? Because what we're going to find is that they're not the same as just adding them up, right? And so we have to be able to do that, right? So more likely scenario is you get a higher percentage off instead of multiple, right? Okay, so same as always, let's outline everything that we're given. So we're given that the first discount is 25%, right, or 0.25. The second discount is 45%, or 0.45. The list price was $32.50. Part A is basically find N. Okay, so we can do that. That's the exact same as what we just did. So N is the list price times 1 minus D1 times 1 minus D2. So N is 32.50 times 1 minus 0.25 times 1 minus 0.45. Dealing with those brackets first, 32.50 times 0.75 times 0.55. I get 32.50 times 0.75 times 0.9. I have a net price of 21.9375. But again, right, the net price is money, so we need to round it to 2 decimal places, so we get 21.94, right? So N is $21.94, right, with proper rounding.
Do you want us to put N always in monetary value?
Yeah, or at least to 2 decimal places, because now in part B, we're going to use N just to 2 decimal places. Right, so if you've established that N is something to 2 decimal places, that's the value that you keep using throughout, right, for parts B, C, whatever, if that makes sense. All right, so part B, right, says what single discount would be equivalent to the 25 and then 45% discounts. Okay. So find a single discount equivalent to 25% and 45%. So what we do, right, now we look at what we have. Yeah. Oh. Oh, sorry guys. 32.50 times 0.75 times 0.55. Oh man. Sorry guys. It's okay, it'll be erased forever. Like it never happened. 13.40625. Thank you. And then down here, 1341.
Imagine plugging that into the next equation.
It's like, oopsie daisies. I can't even remember what it was. It's long gone. All right. So we have the net price now, right? And we have the list price. And we know that there's a single discount that would take that list price to that net price, right? We can find it. And so now we have this formula, N is L times 1 minus D, right? Mm-hmm.
I get it.
Yeah. So we have the net price, we have the list price, now we can solve for D. Right? Yeah. Well, it's 2 parts, right? A and B. So it'll just kind of walk you through it. So the net price, the right net price was $13.41. And the list price was what? $32.50. Times 1 minus D. because we're solving for D. I'll put a little note here. All right, so solve for D is what we're doing here. Solve for a single discount. That makes this happen. Okay. So solving for D, we did that probably second example that we started with, right? So same scenario, just a little bit more involved, right? And so we can divide both sides by 3250. So 1341 divided by 3250 is 1 minus D. 1341 divided by 3250 is 0.41261535. Here's where I do my simultaneous switcheroos. Right. So technically, here, I'll write out what I'm doing technically, and then how I do it just in my head, right? So to move the D to the other side, we would do 0.41261535 plus D, right, is 1. And then we would move the 0.4 over to the right-hand side by subtracting it from both sides, right? So we get D is 1 minus 0.41261535. So then on my calculator, I'm going to make this my 0.4 negative, and then add 1. So I get D, the single discount has to be 0.587384615. So the single discount equivalent to 25% and 45% is 58.7%. I'm just kind of winging it, right? Because I didn't specify, or it doesn't specify, leave your answer to 2 decimal places or whatever. But if you'd like, we could go 0.74. Yeah.
So when we're finding the single discounts, like it's okay to use the rounded value for them?
Yes. Yeah. Yeah. If you're using a value that you found before, use the rounded value. Yeah, you don't have to go back and figure out what it is. Yeah.
And that's why you can't add the 2 discounts.
That's right. Yeah. Yeah, so the equivalent discount is not just adding up the discounts and applying them, right? It's going to change because first you take off 25% and then you take off 45% off of the already discounted one. So it's going to be a little bit different, right? But a single discount of 58.74 is the same thing. Right?
Is the same thing
As 25 and then 45. Okay. Okay. So, any questions about that? Let's talk markups. Yeah. I'm pretty sure. Yeah. So if you're a store owner, right, you know that the selling price is going to contribute to 2 things, right? The cost that you paid to acquire this item to sell it, right? And then some markup, right? And then that markup is going to cover your expenses, right? Your overhead expenses and your profit, right? That's why you're doing it. Okay? So we know kind of intuitively that the selling price is the unit cost plus the markup. Where the markup is made up of two things. So the overhead expenses plus the profit. Okay. So now we're moving on to the next couple of formulas on your formula sheet, right? So we need to define things like S, C, M, E, and P. Okay. So let's just outline what they are. So we let S, capital S, denote the selling price. Capital C is going to be the per unit cost. Right? If I'm a retailer, right, that's the same as the net price, right? The net price is the price that I pay to acquire a product, right? And so that is the per unit cost that I'm paying, right? So there's a link there.
So are they interchangeable if you find N?
Yes. But just remember that on here, that N and C are the same, right? If we're at the same level of the distribution chain, that's the only caveat, right? But we would be. Okay. Capital M denotes the markup. E denotes the overhead expenses, just because a capital O looks like 0 and it's kind of messy, right? So we had to pick a different letter. So the overhead or operating expenses or if you just want to think of it as expenses, that's fine too. And finally, P, you guessed it, is the profit. So from here, right, and what we just established up here, we can develop some simple formulas that we can work with, right? And so we can develop some basic formulas. Like S is C plus M. Right? The selling price is the cost per unit plus the markup. Where M is the expenses plus the profit. If we want a longer version, right, depending on the information that we have, right, we might want to use the formula where we substitute our M into the first one, right? And so we can write so we can write things like S is C plus M, but M, C plus M is E plus P. So S is C plus E plus P. If you have a look on your formula sheet, right, in the left-hand column, right, those are the next 3 formulas that are on here. So I guess I'll kind of square them in. This little guy's on your formula sheet. Yeah. You'll get this exact formula sheet for all the tests and the final. Right? So it's not going to change. Now you have it so you know what you'll have, right? You'll just have to use my clean ones. then you'll be disappointed to hear that you'll probably have them memorized by the time you're done practicing. Disappointing, I know, but that's just how it goes. Okay. So those are the three formulas that we have on our formula sheet, right? So depending on what information we have, right? There are scenarios where we don't know the expenses on the profit, but I tell you the markup is this. Right? Exactly. And we'll kind of learn to weave in and out of these guys. So let's start off a little bit slower and say example 86. A retailer of speakers purchases his stock from the manufacturer for $64.29. Right, so that's how much he pays for these speakers. So that would be the cost, right? The per unit cost. Okay. So in order to determine his selling price, he adds 15% of the cost for overhead and 20% of the cost for profit. A little sneaky. Okay. What is the selling price of the speakers? So let's just outline what we have here. So we're told that the cost, $64.29, okay, and we're told that the overhead, right, is 15% of the cost. Right? So we can write it out as 0.15 C, right? 15% of the cost is 0.15 times C. Okay. Just writing it out in general first. And the profit, same idea, is just 20% of the cost, so 0.20 times cost. And then we want to find the selling price, so find S. Now, even though we know the cost in this scenario, right, we could calculate it right away, but it's good to get in the habit of leaving them as variables, right, because there are going to be scenarios where we're dealing with multiple variables, and so we don't want to plug them in, and when we could just collect like terms and make our life easier later on. Okay. So there are lots of ways that we could solve this, right? You could find the expenses and the profit independently and then just plug them in. Right? So we want to find the selling price. Right? And so we're going to use the third formula, 1, 2, 3, yeah. Cost is the expenses plus the profit. So plugging in our values, or even if we just want to say, leave the cost as is, right, as a variable for a little bit longer, then we know we'll have C's in all of those terms. And then we can collect the C's, minimize some work here. So we're going to write C plus 0.15 C plus 0.20 C is S. Pulling out that common C, right? Or even if we look at this and say, okay, that's going to be 1 C plus 0.15 C plus 0.2 C. So there's 1.35 C's. We can skip straight to that. Okay. And then we know that C is 64.29, so now we can just plug it in. right? Instead of plugging it in and solving for them individually, right? Writing them as variables saves us a little bit of time and calculations later on. So we have 1.35 times 6429. So 1.35 times 6429, I get 86.7915. So the selling price is $86.79.
Could you just go over one more time how we got to 1.25? C by
Mhm.
itself is 1C.
Yeah, technically C on its own, right, is just one C.
Oh, and then you add the 0.15 and the 20 together. Okay.
Yeah.
Thank you.
Cool. All right. Any questions about that one? All right. So like I said, there's lots of ways that we could solve that. Okay. But that's kind of how I chose to solve it. If you want to go through it a different way and you get the same answer, you did it. Great. How about example 88? Oh, this one's got a super curve. Whoa. I gotta start over here. Yikes. Okay, so example 88. After a markup of 32% of cost for overhead expenses and a markup of 37% of the selling price for profit, a car dealer sells used cars for $14,995. At what cost did the dealer purchase these cars? Okay. This one gets confusing, but we have to be a little bit flexible when we're reading these questions, because if we were talking, right, even if we're only talking about the overhead expenses, we would call them a markup, right? We have to mark things up to cover our expenses, and we have to mark things up to cover our profit. And so even though it says after a markup of 32% of cost for overhead expenses and a markup, so it makes it seem like we have two markups, right? But together, those are just one markup, right? So we have to be a little bit flexible when we're reading these questions, because sometimes we talk about them a little bit differently, right? But that said, we're given the overhead expenses, E, is 0.32 times the cost. And then the profit, we're told, is 37% of the selling price. So 0.37 times S. Okay. And then we're told that the selling price, S, is $14,995. And we have to find at what cost did the dealer purchase these cars? So find C. There is. We have S, we have E, and we have P, and we have to find C. No, it's right here. It's the third one down. Or the fourth one down on the left-hand side. S is C plus E plus P, right? That's on your formula sheet. Well, yeah.
Yeah. I.e., there's work involved.
Here's one thing. We're going to do the exact same thing that we did earlier, right? Even though we know the selling price S, for a little bit longer, because I see an S in my P as well, right? I'm gonna leave the S as an S so I can collect like terms and then plug it in. Yeah, because we have to find C, right? So here, I'm gonna rewrite this as S is C, which I'm trying to find, plus E, which we decided was 0.32 times C, plus P, which we decided was 0.37 S. We do, but I'm leaving it out so that I can collect like terms. You can plug it in if you want. You can, right? As long as you get to the same answer as I do, you did it right. Okay. So from here, now I'm going to collect like terms, which means I'm going to bring the 0.37S over to the left-hand side. Okay. So I get S minus 0.37S is C plus 0.32C. Okay. So now, okay, we can pull out the common multiples, right? S and C on either side. So we have S, I'll show my work this time. S times 1 minus 0.37 is C times 1 plus 0.32. Okay. Or if you want to skip that step and just go straight to the combined coefficient, that's fine too. 1 minus 0.37 is 0.63, moving the S to the right-hand side of the value, not the equation. And then 1.32C. Now, because I know S, I'm going to throw it back in, right? But this way, I only have to do it once. So 0.63 times 14,995 is 1.32C. So 0.63 times 14,995 is 9,446.85. And it just is 2 decimal places, so I haven't rounded or anything. 1.32 times C. Solving for C, I get 9,446.85. Oops, 85 divided by 1.32. So C must be 7,156.704545. So the per unit cost is $7,156.70. Yeah. Yeah, yeah, because the coefficient of just the C is technically 1. Yeah, totally. Okay. Any other questions about that one? Stretch. It's allowed. Yeah. Except I can't see people in the back, but I can hear them. Not right now, you're being good right now. Okay, let's do another example. Example galore today. Example 90. Mostly because the hardest part with these questions is figuring out what you're given here. And this one I like because it's fun to say. Cutie Pie Cosmetic Supply. Example 90. Okay, Cutie Pie Cosmetic Supply obtains boxes of hair dye for $230 per box less 30% and 10%. So the price is set to cover Cutie Pie's overhead of 20% of the selling price and to provide an operating profit of 18% of the selling price. What should the retail price per box be? Rewording that last question. Right, so yeah, so the hardest part is keeping track of what everything is here. Okay, and it gets confusing, right? Because now we have discount rates and we have the selling price and the cost and all that fun stuff, right? So now we're kind of morphing all our formulas into one, right? But let's just list what we have here. So the list price is $2.30. The first discount is 0.3. Now I'm ditching the percentages, right? And the second discount is 0.1 or 0.10. I like to throw the 0 in there just because it's 30% makes 0.30, but it doesn't matter. Okay. Where do you see? Oh, the price. So the retail price is the selling price. Let's make a little note here, right? The retail price is the selling price. Yes. And so, no, not necessarily. Because the list price is the price that the manufacturer is suggesting, right? But Cutie Pie has the right to bump up the price even more if they want, or decrease it if they need to, right? So the 230, oh, it's because it's in conjunction with the 30 and 10%. But it is also because the cost is going to be the 230 less the discounts. Okay, so what else are we given here? We're given that the overhead, right? And we've kind of been dealing with these things in different realms. So I'll start a new column of information here, right? So the price is set to cover Cutie Pie's overhead expenses of 20% of the selling price, and to provide an operating profit of 18% of the selling price. And we want to find S. Okay. This one's a little bit sneaky, right? Right. So we want to find S. Right? And so we know, because we have E and P, right, the formula for S that we would use is S is C plus E plus P. Right? So I should write a little note. Formula we need to use to find S, right? Just because we know E and P, right? But we don't know C, right? So C is the cost, the per unit cost to Cutie Pie. C is the per unit cost to Cutie Pie, right? Which is also the net price, right?
On the same level of
Which is also, exactly, which is also the net price exactly. Right. Which is also the net price to cutie pie, right? That's the only reason it works is because they're both to cutie pie. Right. If we were talking about the distributor that cutie pie bought it from, right, it would be different. We won't. Yeah, we can, but we won't. Okay, and so in this case, C is the same as N. That's right. So we find N. N, we know, is the list price times 1 minus D1 times 1 minus D2. And we're given the list price of $2.30. And then the discounts of 30 and 10%. So $2.30 times 1 minus 0.30. Don't forget that 1 minus, right? We get carried away sometimes. Forget the 1 minus. Makes a big difference. 1 minus 0.10, pun intended, I guess. Big difference. 1 minus is a difference. $2.30 times 0.70 times 0.90. So we have $2.30 times 0.7 times 0.9. I get $144.90. Great. So that's the cost to Cutie Pie to buy this box, right, of hair dye. Per unit cost. So now we can set up our formula. S is, I didn't do any more work on that, did I? Nope. S is C plus E plus P. We're trying to find S. We were just told that the per unit cost, or we just found, I should say, is $144.90. And the overhead expenses are 0.2S and the profit is 0.18S. 0.20S and 0.18S. Okay. So now we want to collect like terms, right? Bring the S's over to one side. So we get S minus 0.20S, and if you want to collect them on before you move them over, that's fine. Minus 0.18S is 144.90. So we get S times 1 minus 0.20 minus 0.80 is 144.90. 1 minus 0.2 minus 0.18. That doesn't, what the? 1 minus 0.2 minus 0.18. There we go. 0.62S is 144.90. So S, home stretch, we can do it. 144.90 divided by 0.62. 144.90 divided by 0.62. Selling price is $233.7096774. So the selling price should be $233.71. Phew.
Why are we minusing this one and plusing the other one?
Where do you mean?
Like, why are we not adding up our like terms? Why are we subtracting our like terms?
Oh, because we had to move the 0.2S over to the left-hand side, right? And to do that, we had to subtract it from both sides.
God, that's horrible.
So notice here, right, we might be tempted to use the list price as the selling price, but that's not the case, right? Just because of how much profit and how much overhead expenses they have. So the list price was $230, right? But they need to make the selling price $233.71. So similar, but not the same. Right. Oof, any questions about that? Yeah.
Is our noodle quiz on this too, or just?
This, no, I'll make another assignment for it. Okay, so we've been talking about the markup as just some value, right? We can also talk about the rate of the markup. Okay, so we can calculate the rate. Calculate the rate of the markup by dividing the markup per unit cost, or by the per unit cost, sorry. The rate of the markup by dividing the markup by the per unit cost. The per unit cost is C. So we denote it by ROMU, rate of the markup. And so the ROMU is M, the markup, over C, technically times 100%, right? Because we talk about rates as percentages. But if you'll look at your formula sheet, right, the ROMU is just M over C, and then you are supposed to know to just multiply it by 100%, right? And I think you would automatically anyways. Okay. So, we can also calculate the gross profit margin, which is, say that again, the rate of the markup. Or we can calculate the gross profit margin, which is the markup over the selling price. So similar, but not quite the same. Or we can calculate the gross profit margin, shorthand GPM, and the gross profit margin is the markup over the selling price, technically times 100%, right, to make it a percentage. Okay. And what you'll see right on your formula sheet, so you have the ROMU and then you have the GPM, and then it continues and it says that the ROMU can be written in terms of the gross profit margin and the GPM can be written in terms of the ROMU. So it just depends on the information that you have, right? If you have the rate of the markup, but you don't have the selling price, for example, but I ask you to find the gross profit margin, then you should probably use the rate of the markup, right? Not try to use the M over S, that kind of thing. Okay. So I'll highlight that these two are on your formula sheet. Just like that. Okay. And I'll just say we could also show that the ROMU is the gross profit margin over 1 minus the gross profit margin. And the gross profit margin is the ROMU over 1 plus the ROMU. That's also on your formula sheet. So it just depends on what information you have and what information you need to solve for. So you've got some choices there. Okay. How about an example? So example 92, let's do. So a merchant has a selling price of $13,500 for a small boat. The cost to the merchant is $9,950. Calculate the ROMU and the GPM. Okay. So same thing as always, right? Let's list the information that we have. Okay. So the selling price, S, is $13,500. And the cost is $9,950. So I'll break this up as two parts. So I'll say find the ROMU. On our formula sheet, right, we just said we have two options for finding the ROMU. Because I don't know the gross profit margin yet, I am not going to use that formula, right? So I'm going to start and write out the one that I will use. So the ROMU, we know, is M over C. Mm-hmm. So need to find M, right? So we need to find M because we don't have it. We have SC and we want to find M, right? So we also know that S is C plus M, right? That's on your formula sheet. And we know S and C. Oh, lucky us. So 13,500 is C, which is 9,950 plus M. Solving for M, we have to subtract 9,950 from both sides. So we get 13,500 minus 9,950. So the markup is 3,550. Exactly. So now we can find that the ROMU is 3,550 divided by C, which we know is 9,950. So 3,550 divided by 9,950, 0.35678,392. So the rate of the markup is approximately 35 point, let's do 2 decimal places, 0.68. If you want to do 1, that's fine too. No.
That's just the time.
So you should convert it to a percentage, but you wouldn't lose marks, no. Yeah. So how about if I ask you to find the gross profit margin? Now we have 2 options, right? We can use either of these because we know the ROMU. Okay. So which one do you want to use? Oh, I'll make a note here. We can use either of the gross profit margin is the markup over the selling price, or the gross profit margin is the ROMU over 1 plus the ROMU. And we've got options. Oh. So I've got a request for the gross profit margin is the ROMU over 1 plus the ROMU. Great. We're going to use the ROMU as the decimal, right? But I'll just do it to 4 decimal places, right? I'm not going to use all of them. And that's okay. So we have 0.3568 over 1 plus 0.3568. 0.3568 divided by 1.3568. I get a gross profit margin of 0.262971698. So GPM is approximately 26 point, still going to 2 decimal places, I guess, 26.3%.
Why does it work that GPM equals ROMU over 1 plus 1? Like, what's the reasoning?
I can show it, but I'll have to cheat a look because I tried to do it off the cusp yesterday. It didn't work out. There's some, it's a bunch of substitutions.
Oh.
And so I reckon that you could put the ROMU is M over S over 1 minus M over S and then cancel, and then S is C plus M. So you can substitute it that way. That's how I would try it, but I'm not gonna write it down here. It gets confusing. Just accept it as fact.
Which way do you find is easier or less?
What do you mean, why are they? Yeah.
That doesn't equal 713.
0.713. Where'd you see that?
I mean, that's.
So, or we could say that the gross profit margin is M over S. The markup was 3,550 over, I think, 13,500. Oh, sorry, over S, yeah. So 3,550 divided by 13. Oops.
Some people are still trying to learn to be quiet down.
Oh, okay.
Yeah, I was getting cute there. Pretended bracket.
262962996.
It should be. Yeah, it should. It does now.
It's okay. You're free to go. See you later. So they'll be the same.
Which one do you find normally has more work involved between the two?